Okay, this is Dr. Jainitya, Professor in the Department of Information Technology at K.S.Rangasamy College of Technology. So the topic for discussion is parallel processing, in which we will be going to see the technique called as pipelining. So this pipelining is widely used in modern processes. Earlier, pipelining will improve the system performance in terms of the throughput. That is how fast your system responds. That is a parallel processing. So pipelining is a methodology in which it enhances the performance of your processor. So the pipelining organization requires sophisticated compilation techniques. So what are the methods in which you can make your processor to execute your programs at a faster rate? Use faster secure technology to build your processor and as well as the main memory. Or you can arrange the hardware so that more than one operation can be performed at the same time. So this will increase your processing speed. And then the number of operations in which we perform per second can also be increased. So these are the different ways in which we can make the system to be executing the functions at a faster rate. So to better understand the concept of pipelining, let us take a traditional pipeline concept that is called as a laundry example. Consider we have 4 persons A, B, C and D. Each have one load of clothes to wash, dry and fold. Let us assume that a washer takes 30 minutes to do the process of washing, and a dryer takes 40 minutes to do the drying, and the folder takes 20 minutes. Okay. If A, B, C, D wants to make use of this process, let us assume A has to do the first washing, drying and folding. So A will take 30 minutes for washing, and then 40 minutes for drying, and then 20 minutes for folding. After A completes a task, it will be given for B. B will take another 30 plus 40 plus 20. And then it is given for C. It will take another 30 plus 40 plus 20. Okay, likewise it goes on. So if we do the processing in a sequential manner, for completing this laundry application for 4 persons, that is 4 loads, the sequential laundry will take nearly 6 hours to complete the work. So what is the solution to overcome this time lag? That is this much time is taking for doing the process of laundry. So if they have learned pipelining, that is if we are going to implement the process of pipelining in this, how much time it will take? So the entire scenario have been changed. Now we are going to apply the traditional pipelining concept. So let us assume that A will be doing the initial task, washing, drying and folding. So by the time A is performing the task of drying, the washing machine is free. So in the meantime, B can do the process of washing. Okay, and then by the time A is doing the drying operation, C can make use of the washing. Okay, then by the time A is doing the folding operation, this can do the dryer. Likewise, parallelly, all the process will happen. So for the same 4 loads of cloths, if we perform pipelining concept, it will take only 3.5 hours. Compared to earlier, we have taken 6 hours for washing this 4 load of clothes. Now it will take only 3.5 hours. So this much time will be reduced, and this much faster the operation will happen when we follow the pipelining concept. That is, parallelly execute the task instead of doing it in a sequential manner. So multiple tasks can be operating simultaneously by multiple sources. So we can speed up the entire operation by increasing the number of pipeline stages. So this is a traditional application where we can apply the pipelining concept. So how this can be applied in a computer? So normally we will fetch the instruction and execute it. We take only the 2 stages execution of an instruction. We fetch the instruction and execute. Let us say we have 3 instructions. First instruction is fetched, executed. Once it is completed, go for fetching the second instruction, execute. Once it is completed, go for the third instruction, fetch and execute. So this is a sequential execution manner. Now The change what we are going to apply is use the pipeline execution where the same three instructions, we fetch the instruction and execute the instruction 1. By the time instruction 1 is getting executed, we fetch the second instruction. And by the time second instruction is getting executed, we will fetch the third instruction. So we have two separate units, one for doing the fetching operation and another for doing the execution operations. So in between it, you will have a buffer. So simultaneously, the instruction is fetched and then passed out to the execution unit. While we execute the first instruction, by the time the fetch unit is free, then we can start fetching the second instruction. Likewise, parallelly and asynchronously, they are not synchronized. This will keep on fetching the instruction and keep it in a queue, and this will keep on executing the instruction and proceed the results. So earlier we have seen a simple stage of pipelining with just fetch and execute. Now if we apply the same idea of pipelining in a detailed manner, we will have nearly 5 stages: fetch, decode, compute, memory and write. That is, fetch the instruction, decode the instruction, that is identify what is the task to be performed for that particular instruction, compute the instruction, that is calculate the values corresponding for that instruction, write on the memory, that is access the memory for that particular operations, and then finally write down the values corresponding for the result of the instructions. So we have 5 stages: fetch, decode, compute, memory and write. So here we have applied the pipeline execution. This is the ideal stage of pipelining, where we have fetch, and then while the first instruction is getting decoded, start fetching the second instruction. While it is in the compute stage, decode the second instruction. Likewise, when we see it in the third clock cycle, first instruction is getting computed, simultaneously second instruction is decoded, and simultaneously third instruction is getting fetched. So within 7 clock cycles, all the 3 instructions will be completed. So this pipeline can be organized in a 5-stage pipeline architecture, where we do the instruction fetch. Through the buffer it is going for the second stage, and between the buffer and the instruction fetch we will have instruction decoder, and then second stage of buffer, then we will have compute, we will have third stage of buffer between the compute and the memory access. If you want to access any memory, access it, and then finally through the interstage buffer, the data can be written into the register file. So even though the pipelining will help us to perform the task in a faster manner, still we have some issues in executing of the pipeline. So suppose for example data hazards, structural hazards, that is data dependency, all will create in a pipelining issues. So here we will take an example where we have data hazard. That is, any condition which causes the pipeline to stall is a hazard. So what is a data hazard is, consider 2 instruction add and subtract. Add is R2, R3, value. That is, here R3 and this value are 100 are added and the result will be stored in R2. And then subtract R9, R2 and 30. Okay, R2 is subtracted with 30. There is R2 minus 30 and the result will be stored in RA. So here when we execute this 2 instruction in a pipeline architecture, the subtract instruction will have a value R2, which can be obtained only when you complete execution of the first instruction. But when we implement pipelining architecture, we will be start implementing this second instruction before we get the final answer of R2. So there we will have a data dependency issues between the 2 instructions. So to avoid that, we have to delay the function of the second instruction till we get the answer from the first instruction and then start performing the process. So this is the way where we can solve the pipelining issues.